Hi guys, we're going to start today by kind of continuing our conversation of solving and graphing absolute value inequalities. So I am going to start with kind of your blank template, and I'm going to start by filling in the middle section. So in this section, we are going to be solving and graphing absolute value inequalities. And I'm going to call this part 2 because we already did part 1 last week. So we're going to focus a little bit this week on kind of expanding our knowledge. So similar to what I did last week, I'm going to use kind of a box to solve and a box to graph, and then a box to solve and a box to graph. So on the front, we're basically going to have 2 different examples that are on there. 2 boxes that have solving in them and 2 boxes that have the graphing that go along with them. So I'm going to go to my next box here. And I'm going to mark this one A, and I'm going to mark this one for solving. And the inequality I have is the absolute value of n plus 2 is greater than or equal to 5. So first of all, a couple things. You may want to get in the habit of really almost making these bars for the absolute value, like extend them so they look a little bit more maybe abnormally long. I don't want you to look back and think they're ones for some reason. So I'm real careful to try to extend mine and exaggerate them a little bit so it doesn't look like that. The other thing is we've done a lot of these branch making with the absolute values, and we can't do any of that until this value is by itself and I get rid of anything else that's with it. So if I want to get this by itself, I'm going to get rid of this adding 2. So the opposite of adding 2 would be subtracting 2. And whatever I do to one side, I have to the other. So this cancels, so the absolute value of n is less than or equal to 3. So now I have the absolute value by itself. So once this is alone on one side, then I can start to do my splitting. So the first time through, I write it exactly the way it is, but I drop the absolute value bars. So it's going to look like that. The second time through, I'm going to have to flip this inequality, and I'm going to have to flip the sign of that number. It's going to be n. It's going to be less than or equal to. And instead of positive 3, it's going to be negative 3. So there's my solving. Now, it does need to be or between them. It can't be and. Because it can be this answer or it could be that one. So I'm going to take this part with me to the next box, and I'm going to mark it A and then graphing, and we'll graph it. So I have A. This is going to be the graph part of it. And I'm going to bring the inequalities that I just came up with. That looks like this. So when I'm looking at these, the 2 numbers they care about are 3 and negative 3. So I'm going to make my number line, and I know 3 and negative 3 need to go on there, but they need to go on there in the place they would normally belong. So like negative numbers would be kind of closer to this end. So I'm going to make sure the negative 3 goes there, and I'm going to put 3 here. You can't just say, okay, this is 3, I'm going to bring it down here. This is negative 3, I'm going to bring it down there. You actually need to think about where those numbers would normally be on the number line. Now, if you want to make more numbers in between these or outside of here, knock yourself out, but you need to at least have those on there. So let's start with this one. First of all, I know it's going to be a filled-in circle or a closed circle at 3. And I know if the letter comes first, the variable, which it does, this is pointing the way the line goes. So my line's got to go that way. Okay, now I'm going to look at this one. This is also going to be a closed or filled in circle. Because the letter comes first, my line's going to go this way, so I know it's going to go that way. So filled in circle. It's going to go that way. Now, if I were trying to think about what satisfies this as an answer, it could be over here or it could be over here. So I could say 5 and 8 and, positive 37 all would fit here. Those would be answers that would work. I could also say anything that would be down here. So negative 20, negative 37, negative 4, and actually all the way up to including negative 3 would work. So realize that by actually getting those, what that means. Okay, let's go to our next one. So we're going to go to B and solve first and then graph. So here's my B. Here's my solve. Now, I will tell you, this one's going to take a little more space, so you just may want to be space conscious just so you can fit it here going down. I will tell you, we do have an extra section of the graph, so if you felt the need to move over to the next one to finish to solve, you would be able to do that on this one and be okay. Okay, absolute value of negative 8a minus 3, so all of that's an absolute value, is less than 11. So definitely you can see there's more going on in here. But the good news is the absolute value is by itself. So that kind of helps us. So we don't have to do a lot to be able to get to the spot where we can sort them and kind of branch out. So I'm going to put the first one down just the way it's written, just without the absolute value sign. Now, the next time I go through, I'm going to have to change this inequality and flip it and change this 11 to negative 11. So negative 8a minus 3, it's going to switch there and it's going to switch there. And now we need to do a little solving. So if I want to get a by itself, I'm going to have to get rid of this and then eventually this. So let's start first by getting rid of the 3. So I'm going to add 3 to both sides. Negative 8a is less than 14. Now, to get this value alone, I have to get rid of this. So it's negative 8 times a. So the opposite of multiplying by negative 8 is dividing. Now listen, as soon as I do that, I know I'm going to have to flip my inequality because I just divided by a negative number. So that means that instead of going this way, it's going to go the other way. Okay, these are going to cancel. I'll be left with a. And then I have 14 divided by negative 8. Now, I'll be honest, that's not going to be a whole number. But probably what I would do is pull out Desmos and see what it does if it reduces or anything else. So 14 divided by negative 8. Now, remember when this comes up, it's going to give you a decimal. But if you see a fraction bar that's in front, this blue bar has a little fraction icon on it. And if you touch it, it'll tell you what it's equal to. So negative 7/4. So there's my first one. Okay, now we're going to focus on this side over here. And we're going to start the same way. We're going to get rid of this. So the opposite of subtracting 3 is adding 3. So negative 8a is less than, if I have negative 11 plus 3, it's going to be negative 8. Okay, now, if I want to get a by itself, I'm going to have to get rid of this negative 8, just like the last one. So I'm going to divide by negative 8. Now again, that means I'm going to have to flip my inequality, because I just divided by a negative number. So that means instead of it going this way, it's going to go this way. So these cancel, I'm left with A. Negative 8 divided by negative 8 is going to be 1. So there's my two inequalities. Now, I'm going to go to the next spot to graph, and I'm going to take this part with me. So I'm going to do B, and I'm going to write graph here. And I'm going to bring my two inequalities. Okay, on my number line, the two numbers they care about are negative 7/4 and 1. Now, with both of these, I know they're going to be open circles because there's no equal to underneath these inequalities that I have. So if I start with this first one, I'm going to do an open circle right here at negative 7/4. Because the letter comes first, this shows that the arrow's pointing this way. That's the way the line's going to go. So open circle. Now if I make to the other one, my change here, open, and because the letter's going first, it's pointing that way, so it's got to go this way. Now, do remember when you have the open circles, that means that this number's not included, but anything after it is. And this number's not included, but anything after this is. So if I was looking for solutions, for example, 1 wouldn't be included because it's an open circle. But anything after that would be. So like 1.1, 1.2, anything that's above that. Okay, now you have a couple examples of doing some of this inequality that we've talked about so far. So go through and make sure that you're going over these to understand them.